approach to the application of data science and machine learning as key tools for the construction of public policies in Colombia by Claudia Reyes. I'm an electronics engineer with more than 10 years of experience in the area of telecommunication and networking security, learned data engineering, and machine learning enthusiast. From Bogota, Colombia, director GDG Club Savannah, Cundinamarca, and woman tastemaker ambassador. Project presentation. Project summary. This project establishes the study and analysis of various socioeconomic variables that influence and determine the generation of the state's social policies in Colombia. Through this project, the state of the art, the problem statement, the background, the justification of the project, as well as the theoretical and methodological framework, which is based on CRISP-DM and implements the analyses corresponding to the select data set are developed. The corresponding descriptive and predictive models are generated through data science and machine learning tools to generate conclusions and proposals that can become a basic instrument for the generation of policies that have a real and profound impact on poor and vulnerable population in Colombia. The analysis implemented in this paper is based on the Gran Encuesta Integrada de Hogares 2021 implemented by the National Administrative Department of Statistics, DANI. This is a survey that requests information on people's employment conditions, socioeconomic situation, as well as the general characteristic of the population. The dataset was analyzed for the 5 main cities, Bogotá, Medellín, Barranquilla, Bucaramanga, and Cali. In addition, the art study of the project was based on several master documents of socioeconomic studies which are described in the bibliography. The courses selected in the learning pathway taken for the creation of this project were Pandas, data cleaning, data visualization, intro to machine learning, intermediate machine learning, and intro to deep learning. Throughout the project, the applied data science topics were data acquisitions, development, testing, and maintenance of data infrastructures, cleaning and manipulation of data from primary and secondary sources, creation of descriptive and predictive models, deployment and supervision of machine learning algorithms, and statistical methods in production environments, identification of hidden patterns from the data. Fundamental methodology for data science, IBM CRISP-DM. The fundamental methodology for data science created by IBM and based on CRISP-DM model is made up of 9 stages, which are Stage 1, understanding the business. Stage 2, analytical approach. Stage 3, data requirements. Stage 4, data collection. Stage 5, understanding data. Stage 6, data preparation. Stage 7, modeling. Stage 8, evaluation and implementation. And Stage 9, feedback. Each of the stages will be developed below. Stage 1, understanding the business and problem definition. The high level of inequality in Colombia is a fundamental constraint to economic growth and social progress. The country has one of the highest levels of income inequality in the world, the second highest among 18 countries in Latin America and the Caribbean, and the highest among all OECD countries. In this context, the Colombian state has generated 13 elements such as socioeconomic stratification and CISBEN in order to generate public policies conducive to mitigating poverty and generating social mobility for its most vulnerable population. Through this study, the aim is to analyze the relevance of various variables involved in public decision-making and the generation of programs whose main objective is to impact the neediest population. Aims of the project. General objective: to analyze the relevance and correlation of targeting tools such as socioeconomic stratification with the public policies generated in the social and economic spheres by the Colombian state. Specific objective: first, to create a base document that allows the application of emerging technologies, in this case data science tools and machine learning, that will serve as a guide in subsequent studies and projects involving public policies of the Colombian state. Second, serve as a reference document in its technical component for the implementation of training program in the area of data science and machine learning within the program Data Science for All and All the Code initiative of the GDG Savannah, Cundinamarca. Stage 2. Analytical approach. Throughout this work, we will apply data science techniques corresponding to describe statistics as well as visualization techniques to understand the content of the data, as well as the introduction of project analysts through machine learning tools. Stage 3. Data requirements. The data collected correspond to socioeconomic information for Colombian dated to 2021 by the World Bank, DANE, Colombian National Department of Statistics, the Economic Commission for Latin America, ECLAC, the Kaggle portal, and the Colombian government's Open Data Portal. All data sets will be working on in CSV format, to which different tools of the emerging technologies listed above will be applied. This will be implemented in the Visual Studio Code editor. Stage 4. Data collection. The primary data set information for this phase of the project is provided below, staging the file name in the CSV format, the source from which it was taken, and a brief description of the dataset provided by the dataset created. General information about the data is also provided. This procedure was implemented for each of the 7 datasets. This stage is described in depth in the article. Stage 5. Understanding data. In this stage, tools are applied that allow in the depth knowledge of the data being analyzed. Likewise, descriptive statistics are implemented. Loading modules and libraries. The following is the import of the modules and libraries requirement for the implementation of the project. In this image, we can see the different procedures implemented for the development of this stage. We can see the visualization of the CSV file is presented, 2. Data frame creation, 3. Determining the dimensions of the data frame, 4. Specific selection of data frame values, 5. Obtaining general data information, 6. Checking the data type, 7. Request a list of unique values, 8. List of unique values and their frequency, 9. Descriptive summary of the data frame. Stage 6. Data preparation. In this stage, all activities are implemented to build the data set to be used in the subsequent stage of modeling. Data preparation activities include data cleansing, dealing with invalid or missing values, remove duplicates and format properly, combine data from multiple source files, tables, and platforms, transform data into more useful variables. The procedures implemented at this stage were: first, identification and deletion of non-type data, identification and elimination of duplicate data, data type conversion, removal of special characters and with space, and finally, separation of data into individual columns for further analysis. Stage 7. Modeling. In this stage, the generation of descriptive model on the set obtained in the previous stage is defined in this first instance. Secondly, the generation of predictive models is defined through the application of machine learning techniques. Stage 8. Evaluation and implementation. Descriptive model. In this stage, in the first instance, all the procedures will be applied. such as diagnostic measures, graphs, statistical analysis, and other processes leading to the implementation of the discrete model that allow to address the problem object of this work in an adequate and complete way, thus achieving the fulfillment of the objective set. Analysis of the socioeconomic stratum variable. In the first graph, it is evident that the strata 2, 3, and 1 contain the highest percentage of population concentration, corresponding to the population with the lowest percentage power and the lowest income. Therefore, it can be inferred that in Colombia's main cities, the majority of the population is in a critical condition in socioeconomic terms. In the second graph, we can observe the following percentage of the representation. Stratum 1, 16%, Stratum 2, 35.6%, Stratum 3, 32.2%, Stratum 4, 10.2%, Stratum 5, 3.59%, Stratum 6, 2.25%. Finally, in the table, we can observe the socioeconomic response by strata. Stratum 1, low, low, Stratum 2, low, Stratum 3, lower middle, Stratum 4, medium, Stratum 5, medium high, and Stratum 6, high. When calculating the means of the socioeconomic stratum variable, the predominance of the stratum 2 can be observed. Analysis of the cities variables. It can be observed that the cities with the highest number of respondents are Medellin, Bogotá, and Barranquilla. It can also be inferred that the number of respondents in the city of Medellin is double the number of respondents in the city of Cali. Analysis of the years of education variable. This variable corresponds to the years of formal academic education a citizen has completed. The variable takes values from 0 to 26. It can be seen that the highest frequency is at 11 years of schooling, which indicates that a large percentage of the surveyed population has a secondary education or less. The following values with the highest frequency correspond to 16, 13, and 14 years of age. These correspond to technical and technological education. Only 1.75% of the population has 19 years of academic training corresponding to professional training. It also shows that less than 0.1% of the population has postgraduate studies. Finally, only 0.3% of the population has doctoral studies. Analysis of the variable work hours per weekly. The range 2 shows the highest distribution of the population with respect to working hours per week. It can be seen that the value of the 48 hours present the highest frequency of occurrence. Analysis of the variable labor income. The following graph allows the analysis of the citizens' income with respect to the socioeconomic stratum and the city in which the citizens reside. Next emphasis is placed on the values of the study variables as they present several multiple inconsistencies with respect to labor income and the socioeconomic stratum where the citizens reside. It is possible to appreciate values that do not make sense even within the same city. Some of the appreciations are described below. The above examples are not isolated cases. However, in order to have more tools for judgment, we proceed to analyze the variables. For example, in the city of Cali, the citizen who answered the survey belongs to stratum 6, the stratum with the highest purchasing power in Colombia. His household is made up of only himself, and his income is $4,300,000. As of today, date March 18, 2023, the dollar equivalent of the Colombian pesos is $1 is equal to 4,848.12 pesos Colombian. Therefore, 4,300,000 pesos colombianos is approximately $900.55. In the same city, a second household citizen has an income of 18 millions and is made up of two people. Therefore, each member of the family has an average income of 9 millions, which is an equivalent to approximately $1,899.06. This family is located in Stratum 5. Continuing with Cali, there is a household with an income of 950,000 pesos colombianos or $199, equivalent on average to one legal monthly minimum wage, regardless of the number of inhabitants of these households, and for this reason it should belong to Stratum 1. The same phenomenon occurs in the city of Bogotá. There is a household in Stratum 4 made up of 4 people and with an income of 11,800,000 pesos colombianos. The average is 295,000 pesos, equivalent to $61.92. Continuing with Medellin, there is a household made of a single citizen without an average monthly income of 4,200,000 pesos colombianos, equivalent to $1,881.56 approximately. This is a more than for minimum wage and is stratified in level 2. Level 2 is corresponding to poor population. Relationship between years of schooling and socioeconomic stratum. This graph shows that 11 years of schooling is the most frequently repeated frequency. It can also be seen that the strata that made up this category are 2, 3, and 1 in order of participation. The low frequency of citizens with university and postgraduate studies is also observed. This confirms the analysis carried out previously. The graph shows the relationship between the socioeconomic stratum and the cities where the GHI is what implement. It can be seen that the highest frequency is the city of Medellin, followed by Bogotá, Barranquilla, Bucaramanga, and finally Cali. This graph clearly shows that strata 1, 2, 3 have predominant participation in all the cities, in contrast to strata 4, 5, and 6 with higher incomes. A statistical analysis of the average income variable. The average income variable is created, which is the result of the division between the variables of labor income and the number of persons per household. In this way, the income for each person in the household is obtained. Next, the statistical analysis of the average income variable is implemented with respect to the age of the surveyed citizens and the socioeconomic stratum in which she was classified. According to the survey on the characterization of monetary poverty and results of social classes in 2020, Danny defines social classes according to the income generated by a household during a month. This income is divided by the number of inhabitants that make up the household. From this point, the following categories are determined. Per class is when dividing the total income by the number of household members. The figure is equal to or less than 331,688 pesos colombianos, equal to $82.23. Vulnerable class is when dividing the total income by the number of household members. The figure is in the range of 331,688 pesos colombianos, equal to $82.23, and 653,781 pesos colombianos, equivalent to $162. Middle class is when divide the total income by the number of household members. The figure is in the range to 653,781 pesos colombianos, equivalent to $162, and 3,520,360 pesos colombianos, equivalent to $872.43. Finally, upper class is the total income divided by the number of household members is more than 3,520,360 pesos colombianos. The first thing we can analyze throughout the entire output is that the average income per person in the household mean is mostly low. For the whole output range to 18 to 63 years, the values of average income per person per month minimum are mostly very low, even below 100,000 or $22.56. This is even below the poverty range provided by Danny. This behavior is present in the sickly between age range. Throughout the whole of set of output, a distributing behavior is observed. The values of average monthly income per person mean do not vary proportionately to the socioeconomic stratum in which they are classified. One would expect the minimum monthly income mean to increase as the level of stratification increases, but this does not happen. There is a very marked difference between the values of the average monthly income per person mean and the average monthly income per person max for the same stratum, even more than 10 times. This fact is repeated regardless of the age of the citizens and is more critical in the lower socioeconomic strata 1, 2, and 3. Another critical situation is observed with respect to the values of average monthly income per person max. It is observed that in the lower strata 1, 2, and 3, these values exceed the social class range established by Danny. The cities who have incomes that place them in the middle and upper class belong to the lower socioeconomic stratification that should correspond to the poor and vulnerable population. This phenomenon is observed throughout the whole of the exit, not its insulation. In this way, the subsidies and social programs delivered to socioeconomic strata 1, 2, and 3 are researching the middle and upper social class and not the vulnerable population for whom they should be intended. Another relevant phenomenon is that which occurred in the strata 5 and 6 with respect to the values of average income per person per month, mean, and average income per person per month max. It is observed that these values are classified within the social classes, vulnerable and even poor. We can observe in the following figure how in stratum 6 average incomes corresponding to the vulnerable social class and even to the poor class are recorded. In all the level, it is evident that the average income recorded that classifies citizens social does not correspond to the socioeconomic stratification to which they belong. With regard to the mean, it can be observed that its value is generally lower in the lower strata 1, 2, and 3 than the value present in the higher strata 4, 5, and 6. The vulnerable population should have low incomes and the middle and upper class population should have high incomes. Finally, it can be observed that the standard deviation values present high values, which allows us to conclude that the distribution of the data is dispersed with respect to its mean. Relationship between average income and years of schooling by city. The city of Medellin has the highest average income distribution, followed by Bogotá, Bucaramanga, Barranquilla, and finally Cali. The presence of low socioeconomic strata 1, 2, 3 are predominant and corroborate the analysis carried out in the variable name department. Likewise, the low population density is evident for the high values of the variable years of schooling. Values such as 11, 13, 16, 17, and 18 years show the highest concentration. Relationship between cities and working hours. Regarding the relationship between cities and working hours, as can be seen in the following graph, for all cities, 48 working hours per week is the value with the highest percentage of representation. This is an expected value since Colombia established 48 maximum working hours for formal employment. The following graph shows more clearly the distribution on average income versus hours worked per week, broken down by stratum and city. There is a high concentration of the population in the range between 40 and 48 working hours. There is also notable presence of workers with an hourly workload between 60 and 70 hours. There are also hourly workloads above 70 hours, which concentrates a large proportion of the city. The following scatter graph provides a deep analysis of the behavior of the average income in relation to the city. In the following graph, it can be seen that the highest population density in the dataset belongs to the lower strata 1, 2, and 3. We proceed to analyze the sector with the lowest and highest average income. The following graph specifies average incomes up to 2 million pesos colombianos. The predominance of strata 1 and 2 in the select distribution is observed. However, once again, the label alert us the situation that indicate an error in the targeting method. Thus, a household in Barranquilla composed of 3 people is stratified as 5, but its average income is 1 million pesos per person. It is also observed that a household in Cali composed of 4 persons is stratified in grade 5, but its average income per person is 62,500. Ratio of average income between 2 million pesos colombianos and 5 million pesos colombianos by city. We proceed to analyze the range between 2 million pesos colombianos and 5 million pesos colombianos. In this range of analysis, the inconsistencies between socioeconomic stratification and average income are more than evident. The labels allow us to test certain about the analysis. Thus, a household in Bogota consisting of 4 persons with an average income per person of 2.5 million pesos is socioeconomical stratified in level 2. A second household in Medellin consists of 2 persons with an average income per person of 3.5 million pesos is socioeconomically stratified in level 3. A third household in Medellin consisting of 4 persons with an average income per person of 4.57 million pesos is socioeconomically stratified in level 1. A fourth household in Barranquilla consisting of 5 persons with an average income per person of 3.42 million pesos is socioeconomically stratified in level 1. This behavior is again consistent across a select range. This indicates that many citizens belonging to the middle and upper social class have socio-economic strata that should correspond to the poor and vulnerable population. Predictive model, decision tree model. First, the data frame on which the prediction will be implemented is created. Next, the prediction target is selected, denoted by the variable y. In this case, the prediction target select is the variable estrato vivienda. In the same way, in this stage, the characteristics are selected. These are columns that are introduced in the model which will be used to make predictions. They are denoted with the letter X. Next, the library scikit-learn is used for the implementation of this model. We also define the type of model. In this case, it is a decision tree. We proceed to make an initial prediction. Decision tree model, model prediction. The next step is to evaluate the construct model. In most applications, the relevant measure of model quality is prediction accuracy. With the MAE metric, the absolute value of each error is taken. This converts each error into a positive number. The average of this absolute error is then taken. This will be the quality measure of the model. Once the model has been created, the mean absolute error is calculated. T-value is 0.48. Based on the measurement obtained, the data is divided in two parts. The data in the first group will be used as training data to fit the model. The data from the second group will be used as validation data to calculate mean absolute error. The data obtained shows a significant improvement. Of course, this will generate a more accurate prediction. A comparison of the two outputs is present. The difference is noticeable. The decision tree model has many configuration options. One of the most important is the depth of the tree. However, in the search for the optimal depth level, two phenomena occur over 15 and under 15. A vital consideration is the accuracy of the data estimated from the validation data. Therefore, the objective is to determine the optimal value between under 15 and over 15. Different alternatives exist to control the level of tree depth, and many allow some parts through the tree to have a greater degree of depth than others. However, the mag-left node argument provides a very sensible way of controlling over 15 versus under 15. In addition, a utility function can be applied to help compare the mean scores of different values for max-left nodes. Important limitation of MAE. The MAE is a measure of the average of the square root of the average of the test error realizations. Error is a numerical random variable and one cannot capture the entire behavior of a random variable with a single aggregation of observations. Random forest. Taking into account the previous result, the random forest model is applied. The random forest model applies many trees in its internal structure. It makes prediction through the average of the individual prediction of the tree that make it up. This model generally has a higher percentage of accuracy in its predictions than the previously implemented model, which consists of a single tree. The corresponding implementation is present below. As can be seen, this value represents a much higher accuracy with respect to the original implementation of the tree model whose initial MAE was 0.48. Likewise, it is possible to observe an important variation in the values of the variable strato vivienda, corresponding to the original data set provided by Danny, and the prediction values generated through the two implemented models. In the three cases analyzed, the prediction values were always different from the original ones. Stage 9. Feedback. The two models developed through this project were implemented in a real production environment. The descriptive model and the predictive model were able to meet all the objectives proposed at the beginning of the work. It was also possible to provide a comprehensive answer to the formulation of the problem. How can data science and machine learning tools become a fundamental instrument for the generation of socioeconomic policies in Colombia? The impact and scope of this project go beyond the initially proposed frameworks and can become a fundamental consultation tool for the implementation of public policies in different areas as well as in different countries and regions. Likewise, this document becomes a relevant guide both for data science and machine learning professionals and for citizens with basic programming knowledge. As all the stage involved in the creation of the data science project are addressed, and each one of them is explained and analyzed in depth. Another relevant factor to take into account is this project was carried out 100% with open source tools, which will allow its massive reproduction. Although the scope of the predicted model was greater than originally established, there are more powerful tools that will increase the efficiency of the models implemented in this work. Conclusions. The socioeconomic stratification instrument does not correspond to the social classification presented by Danny. The average income per household does not correspond in a high percent with the range of socioeconomic stratification to which they were classified. The instrument of socioeconomic stratification is not a targeting instrument that allows the identification of the poor and vulnerable population of the country. Therefore, the subsidies and social programs generated by the government do not impact the neediest citizens. Violate the constitutional principle of solidarity with respect to income distribution. The tools corresponding to emerging technologies such as data science and machine learning are fundamental instruments for the generation of any type of public policy in any area or region of the world and must become an all governments, public entities, and organizations involved. Data science and machine learning tools democratize knowledge, empowering citizens, especially the poor and vulnerable population, by allowing access to an analysis of relevant information for the construction of public policies that have an impact on them. In this way, they are able to contrast and even argue against the figures provided by governments and demand the generation of policies that lead to minimizing the inequality and injustice figures that are present in the country. Education is the most powerful weapon for the transformation of humanity, and emerging technologies have the potential and the ethical responsibility to become the key instrument for reducing inequality not only in Colombia but also in the Latin America region. The shortcomings present in the targeted instrument socioeconomic stratification is a fundamental factor in income inequality in Colombia, which is the highest among all OECD countries and the second highest among 18 LAC countries. The three predicted models implement corroborate the findings of the descriptive model. The targeting instrument, socioeconomic stratification, present insurmountable shortcomings which had already been analyzed and warned by different groups of experts and international organizations. However, this work allows corroborating and supporting its conclusion through the implementation of data science and machine learning tools. Bibliography. The bibliography of this project is present below. In this are described the master documents on which this project was based. Special thanks. Fifthly, I would like to express my gratitude to the entire KaggleX BIPOC project team for this life-transforming and community-transforming initiative. All their dedication, effort, and support in providing us with incredible tools for training and growth have borne fruit through the creation of a global community unit by the love of data science and machine learning, constantly supporting each other and focus on generating high-impact projects and developments. Secondly, I would like to thank my mentor Sagarga Napanini, a source of inspiration in my professional development, whose guidance and support enabled me to exceed the goals set at the beginning of this program. Special thanks also to mentor Mani Sakar, who was always there to support us all, for taking the time and effort to take us as his own mentees. Thanks to the team of mentors who were always willing to guide us and share their acknowledged regardless of schedules. Their commitment to our development was fundamental in this process. I would like to extend my thanks and appreciation to all my colleagues for their constant support, their continuous willingness to create community, and of course for all their effort to successfully complete this program. Let's keep in touch. Thank you.